is part 2 of the sensorless FOC bring up chapter. From previous video, we entered the motor parameters and operating limits in the GUI. In this video, I'll give you tips on using an LCR meter to gather your motor resistance and inductance, as well as how to enable and use the FOC auto-tune feature. Again, here's the order we recommend. First is to use your motor manufacturer datasheet. Second is measuring using an LCR meter. And third, if neither are available or you need a fast starting point, use the firmware's auto-tune feature. From these three options, we trust the motor manufacturer first, then manually measuring with an LCR meter. And auto-tune is useful, but it's primarily a way to get a motor spinning quickly. It is not guaranteeing to produce optimal values for peak performance. So some adjustments and fine-tuning will be required afterwards. Now, if the datasheet is missing key values, especially the resistance and the inductances, then your next best option is an LCR meter. When measuring on a permanent magnet synchronous motor or a brushless DC motor, remember the inductance can vary with rotor position, so you might see a range of values instead of a single number. A practical approach is use the smallest inductance you measure as a starting LD, and the largest inductance you measure as a starting LQ. For phase resistance, measure per phase. Now, if you don't have a datasheet and you can't measure using an LCR meter, or you just want a faster path to good enough, that's where auto-tune motor ID, specifically MID1, becomes useful. MID1 will identify the motor winding resistance and motor winding inductances, LD and LQ. It does this using the actual inverter and sensing chain on the EBK, which can make it a convenient option for quick evaluation. Some key expectations: MID1 is a starting point. It helps you get the motor brought up and running, but it does not automatically mean you're at optimal performance. Fine-tuning is still required afterwards. So here are the steps to enable the auto-tune feature. Let's walk through those. So here's the Kyle project. You will go to your source folder under the config features.h file. I already have it open. You will scroll down to line 235 and 236. Uncommenting line 235 will enable MID1, which is your motor ID routines, which calculates the motor winding resistance and motor winding inductances. Line 236 is for your PI gain calculation. So once you have these two uncommented, go ahead and save the project, rebuild, and you will reflash your device. Okay, so it finished building. Let's go ahead and download. It finished downloading, so let's go back to the GUI. One of the things you'll notice on the GUI is you'll see this warning, check ATPI status. This is basically indicating that you have your auto-tune enabled. And you will also see under the tuning tab, you will now see auto tuning here. And this is auto tune feature. Here's a step-by-step on how to use the auto tune feature, specifically MID1. MID1 will again give you the motor winding resistance and motor winding inductances. To run MID1, you first go to the auto tuning tab shown on number 2. In this MID1 section, click on Start. The GUI will then acquire RS, LD, and LQ. If you click on Update, this will automatically populate the parameters in the Config tab. So let's go ahead and run this. Make sure you're writing all parameters. At the bottom, you'll see writing all parameters. After a couple seconds, it will go away, and this will turn green. Make sure to also have this in torque mode. It will not work in speed mode. Make sure this is in torque mode. And now we're ready to click start. Make sure there's no load on your motor. You'll see it move a couple times. So from this, we can see that we have an LD of 25, LQ as 14, and the winding resistance, the motor winding resistance, is calculated as 0.08. Now, if we compare this, so it looks like the motor winding resistance was pretty close. and the LD and LQ are also fairly close. Once you click update, this will actually update these values here. Once you have reasonable motor parameters, the auto-tune feature can also calculate the starter PI gains. This is called ATPI. ATPI uses known motor and system parameters to calculate the KP and KI values for current and speed PI controllers, which can significantly reduce bring-up time and help avoid instability from poor manual gains. This slide will show you how to use the PI controller auto-tune feature. So once you've entered the motor parameters from datasheet or from using an LCR meter or using the MID1 auto-tune feature. So what the PI controller auto-tune feature will do is calculate the KP and KI gains for both ID and IQ currents. So to use the ATPI feature, you will go to the auto-tuning tab and it will show you the ATPI section here. You will click on calculate and then PI update. So the PI controller auto-tune feature will use these motor config values to compute the KP and KI gains. So let's go here. We will click on calculate. It will automatically calculate those values. You will click PI update. Once you click PI update, it will automatically enter the values in your controllers tab shown here. Okay, so that is part 2. Next video, we move into the first motion milestone, open loop align and go. We'll start conservative, get a smooth first spin, and then establish a stable baseline before we transition into estimator closed loop.